In this presentation, I'm going to offer an introduction to some two-dimensional roughness parameters. In the BEX image space here, you can see we have the AFM data as highlighted in the previous presentation, with the cross-section shown corresponding to the midsection horizontal line here shown in the image space. Just want to focus on the box I'm pointing to in the lower part of the screen here. These are X, Y and Z positions and X and Y data points in the three-dimensional space. So if I just move the crosshair up, and if you look towards the lower box there, as I move the crosshair, you can see those values change. So this is a way actually of just getting basic information about the surface by just using the dimensional information here provided by moving the cursor. That also works in the other view. So if I'm interested in this peak, I can get the dimensional position of that in X, Y, Z, and this peak, again, I can get the dimensional information in X, Y, Z, and then determine the parameters I need, distances apart, etc. Let's go back to the roughness. On the information box here on the left, you can now see we have some parameters. 2D parameters and 3D form parameters shown here. If I just left click on that, you see straight away we have some very simplified parameters appear. We've simplified this for this presentation, and we're just using the common notation here of roughness parameters, RA, RQ, etc. These are standard parameters. They've been used for many years for two-dimensional characterization of surfaces. I'm going to detail those in a lecture, which I'm also going to post onto the website, so that you can get a much more in-depth understanding of what these parameters are. These are quite simple, but actually they can quite quickly become quite complicated. But for the time being, let's just have a look at what these are. So RA is a standard parameter. It's the arithmetic mean of the surface, and you can see here we have a value sub-micron, 176 nanometers for the RA. RQ is it's the RMS value, the root mean squared value of the surface data, corresponding actually to the standard deviation, one standard deviation as well, of the surface. RP is the height of the highest point in the 2D section. So you see a value there, 0.459, and if we scan the 2D section here, you can see that roughly, you can see from the vertical scale here that these highest peaks are at that value. RV is the arithmetic value of the lowest point, and that has a value 0.632, and if we scan here, you can see there's a valley over here, which is the lowest point in that 2D section. RT is simply the distance between the highest point RP and the lowest point RV, giving us a total range of the amplitude of the surface. The remaining two here are quite detailed and really cover some statistical analysis of the data. So R skew and R kurtosis are also shown. Just to finish this off, I've actually loaded in the company software representing this surface, and that will be shown in the next presentation.